This video looks at the topic of indices and surds. So an indice or an index is just a power, so something multiplied by itself repeatedly. A surd is just a root, so that would be square root, cube root or otherwise, that cannot be written as a rational number, so i.e. it's a fraction, a whole number or a terminating decimal. Let's look at the properties and rules for both then. First one then is that something to the power a multiplied by the same something to the power b, all we need to do then is add together the powers. So in this case, x to the power a times x to the power b equals x to the a plus b. If we take a few practical examples of this then, so something like x squared multiplied by x cubed, then that's just going to give us x to the 2 plus 3, or x to the power 5. So if you think about it, x squared is just x times x cubed being x times x times x, so it's kind of apparent that that should be x to the power 5. Next one then, x to the power 7 multiplied by x to the negative 3, well that's just going to give us x to the 7 plus minus 3 is the same as taking away 3, or x to the power 4. X to the power a half multiplied by x to the power 3 quarters then, again, it's just going to be a half plus 3 quarters. Again, like always with fractions, look for a common denominator, so 2 quarters plus 3 quarters gives you x to the 5 over 4. If there's numbers or coefficients, give them their proper names in front of the x's, well, we'll just deal with them separately. So if we had 3x to the power 6 times 7x to the power 4, do the 3 times 7 part first, so 21. So x to the power 6 plus 4 for our power, 21x to the power 10. Okay, if the base is a number instead of x, say something like 2 squared, and we were multiplying that by 2 to the power 6, then that would just give us 2 to the power 2 plus 6 to the power 8, and if you go through then that would be 2, 4, 8, 16, 32, 64, 128, 256. Okay, next thing then, if you're dividing two things, all we do is subtract the powers. So if we have something like x to the power 7 over x squared, that's just going to give us x to the 7 minus 2, or x to the 5. And again, if you think of that in terms of common factors, then x to the power 7 could just be thought of as being x squared times x to the power 5 over x squared, which is just clearly x to the power 5. Okay, another example of that then would be if you had x to the power 8 over x to the minus 1, that would just give you x to the 8 minus 1 is the same as plussing, so that's going to give you x to the power 9. Again, dealing with coefficients then, if we had 10x cubed over 5x squared, then 10 over 5 is going to give us 2x to the power 3 minus 2, or just 2x. Okay, so again, dividing through the powers and then just dividing the number part as you normally would. Okay, negative indexes then. A negative index just moves the thing from the top of a fraction to the bottom of a fraction, or vice versa on some occasions. So if we had something like x to the negative 4, that just means 1 over x to the positive 4. The reason being is because there's an invisible 1 at the front here. X to the negative 2/3, again remember there's technically a 1 here, it's just 1 over x to the 2/3, so again move it to the bottom. 7x to the negative 6 then is, just be careful with this one, so the 7 goes in the top and stays there still, and it's the x only that moves to the bottom, so x to the power 6. Again, fraction of half x to the negative 8, the half stays as is, and it's the x to the power 8 moving to the bottom to become a positive. So negative indexes move it from top to bottom of a fraction. Okay, if you're powering something up with a bracket, all you do is multiply the power by that thing. So x to the power a, all to the power b, is just xab. And that applies to anything in the bracket, everything gets raised to the power b. So if we had x to the power 4 cubed, that's just going to give it x 4 times 3, or x to the power 12. And if you think about it, x to the power 4 cubed is just x to the power 4 times x to the power 4 times x to the power 4, which is clearly then x to the power 12. Just as a double check. Okay, 5x squared to the power 4 is just going to be 5 to the power 4 x to the 2 times 4, so that's going to be 5 to the power 4, 625, x to the power 8. Another example, 4xy cubed, then it's just going to give us 4 to the power 4, x to the power 4, y to the power 12, so that's 256, x, y, 12, put the 4 back in as well. Okay, next thing then, our fractional indexes and how that relates to powers and roots. You raise it to the power at the top, you take the root of the number at the bottom. So if we take the most common example then, x to the power a half, that's just x to the power 1, and we take the second root. Okay, so that's just obviously just x squared. Okay, if we take x to the 2 over 5, again, raise it to the power at the top, take the root dependent on the number at the bottom. X to the negative 3/4. First of all, deal with this negative, so that's just going to be 1 over x to the 3/4, or 1 over x cubed, and take the fourth root. Okay, dealing with a number then, 8 to the 2/3 is then just 8 squared, and then cube rooted. Okay, this question is actually easier if we think about it as being the cube root of 8 first. So do the root first and then square the answer. The cube root of 8 is 2, because 2 times 2 times 2 gives you 8. So that just gives us an answer overall of 4. Okay, next we have to look at our surds. So the root, in this case could be any root, we've just drawn the square root, of the product AB is just the product of the root of A times the root of B. So something like the square root of 80 then, and what we're looking for here is 2 factors of 80, and preferably one at least being a square number and as big a number as we can make it. So the biggest square number I can divide in 80 is the number 16, so let's choose that one. And 16 is just 4 when you square root it, root 5. So root 80 is 4 root 5. Similarly, you can do this property in reverse. So 3 root 15 is just the square root of 3 times 15, which is the square root of 45, which is the square root of 9, square root of 5, or 3 root 5. Okay, so you can use this both ways. Similar holds up with fractions. So if you had the square root of 8 over the square root of 4, well, clearly we could just break that out to be the square root of 2 multiplied by 2. Okay, so the square root of 8 being root 4 root 2, or 2 root 2, over 2, which is root 2. Or we can use the property above and say then that that is just equal to 8 over 4 all square rooted, which is just the square root of 2. Okay, quickly recapping then. X to the power A times x to the power B is just x to A plus B. So you add powers when you're multiplying, you divide powers when you are, when you are dividing powers you subtract. If you raise to the power B outside the bracket, everything gets raised to the B. If you're looking at a negative index, it's just a case of moving it to the bottom of the fraction and change it to positive, or vice versa to the top if it already was on the bottom. X to the power A over B is just x to the power A and the B root. Okay, I'll take the root dependent on B. Remember, in some questions it will be much easier if you take the root first and then power up. The square root of AB equals the square root of A times the square root of B, and similar holds true for fractions.